This is problem number 4 on the practice problems for quest number 5. Perform the indicated operation and reduce to lowest terms if possible. Part A, 3x plus 6 over x plus 4 times 2x minus 4 over 5x plus 10. You're welcome to just go straight across and start foiling everywhere, but if you do, you're not going to end up with the most simplified answer possible. The main idea with just about every problem on this page is to factor first. So let's factor everything we see here. So in the top left, we can pull out a 3. Bottom left, nothing to do there. Top right, pull out a 2. Bottom right, pull out a 5. And anything you see that's exactly the same upstairs and downstairs gets to cancel because everything is now multiplication. So I see x plus 2 and x plus 2, and that's about all that I see. So we're ready to just write the final answer here. I'm going to merge the 3 times 2 and get a 6. X minus 2 upstairs, x plus 4 downstairs. Don't cancel the x's. You're welcome to distribute the 6, but you're also welcome to just leave it as it is. Oh, we're missing the 5, so don't leave it like that. Leave it with the right answer, with the 5. Part B, 35x squared minus 25x over x squared minus 36 times x minus 6 over 15x to the 4. Again, factor first. Factor everything that you can factor. So top left, we're pulling out a 5, and we're also pulling out an x. Bottom left, difference of 2 squares. Top right, nothing to do. Bottom right, nothing to do. And now again, it's all multiplication, so cancel anything you see that's exactly the same upstairs and downstairs. Fix one of my 6's here. Okay, so what cancels? I see an x minus 6 and another x minus 6. I see a 5 can go away with this 15 and leave 3. And then finally, last thing I see is x, this x right here in the front, and one of these x's, which leaves me with an x cubed down there. Okay, so then we just copy our answer and we're done. So what remains up on top is just 7x minus 5. Downstairs, there's a 3 sitting in the front. I'm also going to bring the x cubed to the front, and I'll copy the x plus 6. And I'll leave it just like that. No need to distribute downstairs. Nothing can cancel. Don't think about canceling any of the x's. Okay, part C, a to the 5th over b to the 5th divided by 2a squared b cubed over 5. So the basic idea here was nothing to factor, but also we want to change division into multiplication. So we keep, change, flip. Keep the first, change division to multiplication. Keep, change, and then flip the second. Okay, everything here is factored already. It's all multiplication, so we're ready to just cancel anything that we see that's exactly the same upstairs and downstairs. So I see a squared. We're going to lose 2 of those a's, which leaves me with 3 a's up there. And I don't see anything else that cancels. The b's look like they might cancel because there was one upstairs and one downstairs, but this b right here wasn't really upstairs. It really needs to get flipped over, so it's downstairs. Nothing else cancels. So we'll just write our final answer down here. 5a cubed over 2, and then what do we do with the b's? You have those exponents and you add them. So again, b to the 8th. Part D. 9x squared divided by x squared plus 12x plus 36 divided by 12 over x squared plus 6x. Okay, I'm going to go ahead and do my keep, change, flip first. Keep the first fraction. Change division to multiplication. Flip the second fraction. Do that first so that I don't think that I can cancel things that aren't necessarily where they look like they are. Next step, factor everything. Top left, nothing to do. Bottom left, okay, just got to factor. Pause the video if you need some time to factor this. So that's x plus 6 times x plus 6. Top right, factor out the GCF. Bottom right, it's fine to leave it as a 12. And we cancel any numerator with any denominator. X plus 6, x plus 6, 9 and 12 reduces to 3 and 4. And it looks like there's nothing else that we can do. So we'll just write our final answer. I'm going to try to squeeze it in right down here. So upstairs we had 3, we got x squared and another x, so that's x cubed. Add those powers. And then downstairs was a 4 in the front, and then x plus 6. You're welcome to distribute downstairs, but there's really no need to do that. Okay, part E, x squared plus 5x divided by x squared minus 9 plus 6 over x squared minus 9. All right, I started off by saying we're going to factor just about everything on this page. Well, you factor because you want to cancel, and you can only cancel when there's multiplication and division. Addition and subtraction is really completely different. You can add these two guys easily because they have the same denominator. So x squared minus 9 stays in the denominator. I'm going to write this. We don't need to put as much detail here, but I'm just really highlighting, well, I guess there's nothing to do there, but just highlighting we add straight across numerator and other numerator. Now that could be the final answer, but the fact is, it's our job to try to factor because if there's something that could cancel, then we should cancel it. So the bottom is familiar, difference of squares. Top, pause the video if you need to, but find the two things that factor to give you the top. I got x plus 3 times x plus 2. And then, oh look, something is the same upstairs and downstairs, so cancel it. X plus 3 is canceled. And we're left with our final answer, which I'll squeeze here. X plus 2 over x minus 3. Don't cancel the x's. Part F, 5x over x minus 7 minus 3x plus 4 over x minus 7. Again, we're quite happy because the denominators are the same. So this equals, we'll copy the denominator, x minus 7, and then upstairs, I'm just going to write it, 5x minus 3x plus 4. And if you do this out, you're going to get the wrong answer. I've made a really easy mistake to make. This 3x plus 4 was one thing, and we didn't need parentheses before because the fraction gave it to us. The fraction showed us that that thing up there was one thing. But all of a sudden, I brought it down here, and it's not one thing until I put the parentheses back. So it's really easy to make that mistake. I'll go ahead and distribute that minus sign through. So minus 3x is fine, but it's a minus 4. It's not a plus 4. That right there is the telltale error. Most common error, I guess I should say. Okay, and then we'll combine terms. Upstairs we get a 2x, subtract 4, not add 4, divide by x minus 7. That answer is fine. Turns out you can factor the 2 out on the top, so we'll do that. And we get this. Nothing left to cancel here, so that's our answer. Part G. 8x over x minus 2 plus 3 over 2 minus x. Okay, the denominators look not the same, but they look quite similar. X minus 2, 2 minus x. We've seen this before. The idea here is that those denominators are exactly the same, except they're backwards. The signs are all backwards. So how do we handle it? Well, I'd really like this to be x minus 2. I want it to be the same as the first denominator. So how do you pay for that? How do you pay for the switching all the signs? You got to make the fraction negative of what it was. And once we've done that, well, now life is good. Denominators are the same. Upstairs, 8x minus 3, and we're done. So the giveaway on this one is looking at those original denominators and saying, wait a minute, they're almost exactly the same. Just one is the wrong sign of all the other terms. Part H, q over q plus 3 minus q over q minus 3. Okay, now we need to start worrying about LCD. So I'll write some of the details. When we did these in class, we had a big space. I don't have as much space here, but let's just start to list as much as we can from what we did in class. So the idea was to factor the denominators separately. There's nothing to do, nothing to factor. And then we had this kind of nice Venn diagram idea. And we would just put any common factors for both into the middle space in here. And are there any common factors for q plus 3 and q minus 3? The answer is no. So we really just have to separate them. And the LCD, once we've got it written this way, is to just multiply everything you see straight across in that Venn diagram. And we get that. No need to FOIL. In fact, it's a bad idea to distribute here. You just leave it as is. And the next thing that we did was copy the original fractions. So I'm going to copy my two fractions, q over q plus 3, and then q over q minus 3. And then the idea was to multiply by the right thing to turn each denominator into the LCD. So what's missing in this first denominator here, q plus 3? Well, it's missing the q minus 3. So that's what we need to put. Q minus 3 there, and there. You got to multiply top and bottom by the same thing. But now the bottom is the right denominator. And what's missing for this guy? It already has the q minus 3. It's missing the other piece, q plus 3. So for this one, we multiply top and bottom by q plus 3. Okay, continuing straight down here, we're going to distribute upstairs. So in my mind, that's got parentheses in it. So we'll distribute the q and get q squared minus 3q over the right denominator, q minus 3q plus 3. The other fraction, distributing q squared plus 3q divided by the denominator. No need to distribute downstairs, we'll just leave it as it is. And now I'm ready to put the sign back in between these two fractions. Was it a plus or a minus? This problem was a subtraction problem. So let's put a minus in between here and then subtract. Okay, so I'm going to write one more step. You don't need to put this step, but you might lose some points if you make the common error that's possible in this next step. I'm just going to copy. I had q squared minus 3q, and then I'm subtracting q squared plus 3q. That's just making one fraction. It's okay now because they have the same denominator. Do you see the mistake that I made? It's the same mistake I made earlier in another problem. This q squared plus 3q is one thing. It all needs to get subtracted, which means I need parentheses there. Now you're also welcome to put parentheses around this. That part doesn't make any difference because there's no minus sign in the front that's going to change everything. But without parentheses around the second, we're going to get it wrong. Okay, so now I think we're ready. Equals all the way through. So let's see, q squared minus q squared. Well, maybe we'll do this in one more step. So I'm going to get rid of the parentheses by distributing that minus sign. And that minus sign right there is the one place that a lot of people are going to get it wrong. They're going to have a plus sign there because they didn't distribute the negative. Okay, and now finally we're ready to combine like terms upstairs. The q squared minus q squared goes away. Negative 6q is all that's left. And then we'll copy the denominator again. No need to distribute there. And that's our answer. It's a lot of work. Okay, going back up to part I. 4x minus 15 over x squared minus 5x minus 1 over x minus 5. Same idea as before, splitting the two denominators. X minus 5, there's nothing to do there, but we can factor the first one, and we should. So factor out the GCF, which is x. And look, we get x minus 5. So there was an x minus 5 in both of these, which means there's some overlap to put into my Venn diagram. So what part is in both? X minus 5. That goes in there. Now we just have to fill in the rest of the pieces. How do we get this guy to be in the left-hand circle? Well, it's missing x. How do we get this guy to be in the right-hand circle? Well, it's already there. If you feel like it, you can put a 1. But no need to put anything there. And then the LCD is the product of all the things in blue, x times x minus 5. All right, so now let's separate these two problems with a line here. So now we'll copy our original fractions. I guess in factored form is the way to go here. So original fractions, but in factored form. So 4x minus 15, I haven't even looked at, but now I'm not going to put the original denominator, I'll put the factored denominator. And then the other fraction, 1 over x minus 5. And then we start asking, okay, what is this fraction missing in its denominator to get the right denominator, the LCD? The answer is nothing. We don't have to do anything with that one. What is this one missing to get the right LCD? It's the x. So our job is to multiply the bottom of this second fraction by x. So we'll put it right down here, x down there, but you can't just willy-nilly multiply the bottom by x without right away at the same time multiplying the top by x. So now we'll copy the first fraction. It's unaffected, 4x minus 15 over x minus 5. And the second fraction we'll just multiply across the top. So we get x on the top. Don't distribute on the bottom. I'm just going to rewrite it in the order that makes it look like the first fraction. Okay, and now we just have to add or subtract. So what does the original problem have? Original problem here has a subtraction. So we're going to subtract these two new fractions, which are equivalent to the ones that we started with. So again, you don't need to put this step. I'll put it, making it one fraction by really just writing out what the two things are that you are combining upstairs. Okay, I'll get the right answer here. I'm going to technically put in the same parentheses that I've been putting in on every subtraction problem. If this were anything bigger than just one term, without those parentheses, I'd get the wrong answer. Probably safest just to put parentheses every time. Okay, and now we subtract. Turns out the parentheses are irrelevant in this problem. So 4x subtract x is 3x minus 15 over x minus 5. And we're just about done, but you can factor something out of the top. So pull that 3 out and cancel anything that's the same top and bottom. And look, x minus 5s are the same. So we can cancel them. We get our final reduced answer, 3 over x. Okay, and then the last part here is part J. 2 over x squared plus 6x minus 9 over x squared plus 4x minus 12 plus 2 over x minus 2. Whew. Okay, same idea as before. We're going to factor all those denominators completely separately. So this denominator, you can factor out x. This denominator, we're going to factor with our two things in parentheses. So pause the video if you need to. I get x plus 6x minus 2. And the last one, nothing to do. It's already factored x minus 2. Okay, so looking for the LCD here. I guess the Venn diagram thing breaks down a little bit. You might be able to get away with drawing 3 circles, 3 overlapping circles, but if you understand the idea that the Venn diagram is supposed to convey, then maybe we can just look at this stuff and decide what the lowest common denominator is. Okay, so the basic idea of the Venn diagram is when you have overlapping stuff, you don't need to write it every time, you just need to write it once. So in our case, I'm just going to start copying things that I see from my denominators. I see an x, I'm going to put an x. I see x plus 6, I'm putting x plus 6. I see x plus 6 again, I don't need to put it again, I've got it already. I do need the x minus 2. Finally, x minus 2, I don't need it again, I've got it. So this is my LCD. And now we're going to start copying our original fractions. So let's bring them down individually. But again, we're going to put the denominators in factored form. And I'll leave a little space next to each of them because we're going to need to make these into equivalent fractions that have the right denominator. Okay, So we're going to multiply each of these things by the right thing, turn the denominators into the LCD. Okay, so in this denominator, x plus 6, what's missing from the LCD? Let's see, I've got the x plus 6 there and there. What I don't have is an x minus 2. So that's the part that I'm going to need to bring in. So let's bring in x minus 2, top and bottom. Okay, next fraction, 9 over x plus 6, x minus 6. I have x plus 6, I have x minus 2, I have x plus 6, I have x minus 2. What I don't have is the x. So we need to put in an x, top and bottom. Last one. I have the x minus 2, that's this one. What I don't have is the x plus 6 or the x. So we need to multiply by both. This is the one that's missing the most. So x and x plus 6. Put them downstairs so that we'll have the right denominator. Put them upstairs because we have to. Okay, so now I'm going to distribute upstairs. So the 2 is going to multiply by the x minus 2. Put parentheses there if you want. So we get 2x minus 4 over, and then I'm not going to write this whole thing out, but what is it? X plus 6, x minus 2. That's exactly the LCD. So I'm going to put LCD. Next one. X times 9, that's easy. That's 9x. What's in the denominator? X plus 6, x minus 2x. X plus 6, x minus 2x is the LCD. That's the point. That's why we put the stuff in green, to turn the denominator into the LCD. And then finally, okay, I've got a 2, I've got an x, and I've got an x plus 6. We'll distribute. You can do this in 2 steps if you wish. We get 2x squared plus 12x over, what denominator do we have here? Well, you might have already seen the pattern, but there's an x minus 2, there's an x plus 6. X minus 2, x plus 6. It is the LCD. If it were anything other than the LCD, then the thing we put down there in green was not the right thing. Okay, so I think we're actually almost done with this one. I'm just going to copy my new fractions there in black. So we've got 2x minus, I'll do this in black then. We've got 2x minus 4 over the LCD. And then was it a plus or minus? All right, so the first one was a minus, the second one was a plus. So the first one is a minus, and then I'll copy my middle fraction, 9x over the LCD. Second one was a plus, and then my last fraction, 2x squared plus 12x over the LCD. And now we get to just start combining like terms upstairs. Again, you don't need to put this step, but I'll write it. Making one big fraction, 2x minus 4 minus 9x plus 2x squared plus 12x. Do I need parentheses? Well, they aren't going to make any difference in this problem, but not a bad idea to just put them every single time. All those numerators need the grouping symbols a lot of the time. Okay, so we combine terms. Upstairs, how many x squareds do we see? Just the 2x squared. How many x's? 2x minus 9x is negative 7x, plus 12x is plus 5x. And then the constant term is just the minus 4 over the LCD. Finally, I'll write the LCD here. X plus 6, x minus 2. So finally, that is our final answer. I suppose if the top were factorable, then we should factor it just to see if we can cancel anything. So it turns out the top isn't factorable, but it is worth spending a minute or two seeing if you can factor the thing.